Let's welcome Thatcher to the stage. He works at Leaf Cloud. He'll talk about sustainability, if I remember correctly. So do please give him a round of applause. Good luck, have fun.
Thank you, guys. Thank you. So today I want to talk about a topic that is very dear and very important to me, which is sustainability. And I also love talking to this kind of audience in particular, because we are a lot of people who actually have the ability to do something about sustainability in our day-to-day job, even if we often don't realize that we do. I did a variation of this talk before, so one or two of you might have seen it before, but it's super important. What I'm going to talk about is, first of all, what is the problem with cloud sustainability? Then I'll try to give you some practical tips and advice of what you can do about it. And then I'll make the case for Leaf Cloud and talk a little bit about what we do on this topic. So my name is Thatcher Peskens. I'm one of the co-founders of Leaf Cloud and have been in the space for quite a while now. So this really is the problem, right? So we see glaciers melting, we see massive forest fires in Spain, in south of France, in Australia, in California, all across the board. We see the effects of the climate change happening today, right? And then this is often scary, like shit, the world is going to shit. I don't know what to do, right? It's too big of a problem. The thing is though, we're only at the beginning, right? It's like a wave and it goes up. And I think Peter already kind of illustrated this nicely yesterday with the show your stripes. But we have the choice actually, okay, do we let it go crazy like this, that our grandchildren are gonna have like a really bad place to live in, or it's gonna be not so bad? So this is something that we can make decisions in and about, and you have control. So what is now actually the problem, what are we doing? We use lost energy, right? This is the coal power energy plant in Eemshaven in the north of the Netherlands. And yes, they have some windmills in the foreground, but really they're just burning a lot of coal. And coal is not the only energy source there. This is a very interesting, different angle on the same coal power plant. You see the big thing in the middle on the front? That's the Google data center. It's built right next to the coal power plant. Why? Because it uses a ton of electricity. And this is not even a picture of it finished, because I think they now doubled in size. So oftentimes they, click, there we go. They like to show this picture, right? We use green energy and so forth. But what you see here also is these blue cooling towers. They're for chilling the building, right? So a data center is essentially a giant building that a lot of electricity goes in, heat comes out, and then they dump it into the air or in the water sometimes also here. And there's more problems about it. I'll get back to that. Okay, so that's, sounds like a lot or something. How much is that really? 3.2 terawatt hours. That's about 3% of all electricity that we consume in the Netherlands. And so if you put that in context, what is that? That's about a third of all the wind energy that we produce. So if you think about it, sure, it's nice that Azure claims, we're super green, we're going to be carbon neutral, and Google, we're carbon neutral, and AWS maybe also, but to have their ambitions. But the issue there is that they still consume the energy, and all the energy, even it being green, that they consume is not available to you and me. I also would like to heat my house electrically. I would like to drive an electric car. I don't have one, but I would, right? And there's a lot of things that we also use that energy for, and currently it is still wasted. Just for other piece of context, NS, like we use 3 times as much Amsterdam without the data centers, right? So that's huge. So back to the kind of like, okay, what is the kind of impact that you have? So this is an interesting question for you. How much CO2 emissions does an 8-core Kubernetes node cause in 1 year? and to be specific, here I use an energy mix number, like not specified green energy or not in a normal data center, not like relatively performant, like in reasonable numbers. Is that 100 grams? Can I see a show of hands? 10 kilograms. Hands? Okay, quite a lot there. Or 100 kilograms. Okay, so most of them are in the middle towards the higher end. So what it is click. Yes, click. Click, yes please. We can do it. 135 kilograms a year. That's 10,000 kilometers by car. Or if you take it for like a GPU, like these NVIDIA ones, they use up to 300 watts each. If you run that for a year, that's 1,000 kilograms. It's massive. And so that's cool. But what can you do about it? Yeah, okay, well, it does click, okay, good. So these are some tips for cloud engineers. The key gist is reduce work, increase utilization, and optimize for place and time. Things everyone can do. So what you should look at is to remove unused and underutilized services. If you have the servers running but you never use it, then shut it down. If it was monitoring something that you don't use anymore, kill it, stop the server. Also, you can build or write it more efficiently. Choose Rust over Ruby, or like Go versus Python and so forth. Oftentimes this is the harder thing to do because it's a lot of work to re-engineer, but when you start a new project, pick it wisely. Do clever caching. Like whenever you don't have to rebuild up a particular request or answer, then it saves energy. And be critical on duplication and over-provisioning. I think it was a very nice talk yesterday from Wekamp to say, okay, so look, we over-provisioned the hell out of it so we could meet this demand, and then we've got to shut it down for 2 weeks or something, and it was very costly for the wallet, but also very costly for the environment. So next up, oh, too fast, is to right-size your resource requests and your limits. Now, actually, just this morning, I had a very nice chat with some of the guys who are in the sponsor booth here. They actually make some kind of automated solution for that to resize your requests so that you can actually pack your server more dense. Because in effect, if you can have one server that has something like 80% utilization, instead of having two that do 40% utilization, you then have actually saved this one machine that actually is otherwise wasting energy. And also make no mistake, even if you use a VM in a data center that is a cloud, they still have reserved memory and CPUs for you. So it's not as if someone else uses it if you don't use it. It is actually reserved for you, at least in some degree. Then the other things here are also like scale down your clusters with auto-scaling if you can. It's a little bit extra work, but it can save you a lot. And even better, if you have testing or development environments, shut them down in the weekend, at night, and so forth. And this kind of also goes to kind of one of the other things that we had in the talk also this morning. Hey, do the scale monkey thing. Test your application. Kind of like having a system that just shuts down your cluster at night or in the weekend, actually also is immediately a test if it comes back up in the morning, which is a test you should run anyway, right? So that actually just helps. And then the third category here is what I call optimize for time and place. So choose where you run. Choose cloud. It's more efficient typically than data centers or than on-premise places where you have more inefficient cooling. Sometimes edge can actually be smart if there you can actually reuse the heat that they produce. Pick the right region. US East, AWS, is notoriously carbon heavy because it's very much coal powered, whereas Frankfurt is better, right? So pick your region. Not in a hurry, you use a queue. If instead of having high peaks with over-provisioning, make a queue so you can spread it out. Less machines, again, less waste. Turn on the power save mode in BIOS. These are all practical tips I would like to give you. I won't do it now, but if you have ideas of other things that I have not mentioned and you'd like to share them, please put them also in the questions app, and I'll go back to that later on. Maybe see if there's some other things that we can, help each other out with. It might even be nice to have an open space after this talk that focuses on, okay, so what can we do about the environmental cases and sustainability? So, click. Well, I then also would like to make the case for Leaf Cloud. So, what we all know is that cloud is a huge drain on the sustainable and in general available energy available. However, it also enables amazing develop productivity, innovation, smartness. We can save a lot of inefficient industry processes by simulating them on computers, and so it also is a big enabler for us. So what Leaf Cloud tries to do is that we try to change the game by changing the design. So what do we change? This is the old situation, or the current one. Oftentimes, you have data centers that contain many servers. They use high power air conditioning and chillers, which is the ones that also evaporate water in these chillers in order to make that process more efficient. And they move all the heat into the air, which is then all gone. Leaf Cloud makes it into this situation, where we put the servers in typically apartment buildings, but could also be hotels or swimming pools, where the heat is actually being reused. So we feed the heat from the server straight into boilers, heating tanks that are then used to feed tap water into the different people's apartments. And all the energy that we feed into these boilers is then substituting other energy sources, such as gas, that then would be used to heat that. In combination with a heat pump, we can do this very efficiently and actually save a lot of energy there. Also for you, if you have questions, maybe already put them in the app. I'll come back to the kind of questions after this. So how much does that save to quantify this a bit more? So, or how does it work? So in a data center, using a common energy mix, which I think is fair because the energy has come from somewhere anyway, even if we have a mix of green energy in the country. Just to power the servers for 1 kilowatt, this is simple math, is 3,500 kilograms of CO2. Next to it, to get 1 kilowatt of heat, you would use 2,390 kilograms or emit this much CO2 in heating that. Now compare that to Leaf Cloud, where we use green electricity, and I still count some of it because I think it's unfair to say I use green energy, so I have no emissions. I think you should always look at the life cycle of this as well. Nobody wants to have a windmill in their backyard and a solar farm in front of their house. So it all has a cost. But effectively what we do is by replacing both of these, the data center and the apartment building, with a single site that emits the heat into where it's used, we actually reduce this number. We eliminate the heating of the apartment building with the heat that we expel. And so, if you do the math, you can see that actually we have a negative CO2 emissions if you look at the scope of the data center, right? Maybe any questions so far? Let me have a look. What impact do we, or what code generation, have on power waste of data center? I don't know what maybe can someone explain what I mean was code generation? Okay. So I can assume I answered the question already. Yes. Okay, thank you. So what about using data centers in cooler regions? Cold temperature is less cooling, is less energy. Of course, yes. So this means, and this is what the whole industry is doing, right? Whenever like a data center of your common place, they talk about sustainability, and what they do is they say, okay, yeah, now we have the most efficient data center. But what they do is they bring down the waste of the cooling, right? So let's say that the server itself is 100 watts. Then in an inefficient one, you spend like 70% extra on the cooling. So they say this is inefficient. So they bring down the amount of extra energy that they add to cool it down. But you cannot go below the 1 because that would mean that you're actually reusing it. And this is typically not what they're doing. So when you see, okay, so do I put my data center in the cooler region? Sure, but it just makes it more efficient to dump the heat that you have, but there's no actual reuse there implemented. How would you ensure security in data centers in apartment buildings, seeing as there is less control on who can enter? This is a great question. I think what would be good is for me to go to the next part of the presentation and actually explain how we do that. So what we've built is a very different architecture for data centers and for cloud in general. We've built a distributed data center. And in this architecture, we have a core to our model, which is in a normal data center in Amsterdam West, in our case. And around that, we have a number of leaf sites. These leaf sites are those places where we actually reuse the heat. And they're connected to each other over dark fiber connections that we manage ourselves. So we put our own modules on there, which gives us incredibly low latency and incredibly high throughput between those, like 100 microseconds. And this also enables us to do this, which is what we call disaggregated storage. And this is not necessarily a new invention of ours. Many times when you start VM in the cloud, one piece of hardware actually runs your VM, and some other pieces of hardware have the storage. We do exactly the same, except then we put them apart. And because the latency between this with the speed of light is so low, the customer won't notice. But we can actually then produce the heat on the leaf side and have the data all stored safely in the data center. Which is really cool, because then also we don't have to make these leaf sites look like data centers. We don't have to have backup generators and like triple power supplies and like everything, because if a site would fail, one of these, we immediately reschedule and move your VM to one of the other available leaf sites, or the core if none are available. Which causes then this place where we actually can think of reliability as a virtual reliability. I mean, this is also not new. Like, you know, I spoke to Twitter engineers years ago, and they told me, like, yeah, you know, it's not the question if a piece of hardware fails. The question is when, right? So if you start to have this, to take this really to mind, you can also up this in reliability just a notch and actually have a very different architecture that you can actually do this. Then we also do full disk encryption and a bunch of other things to make sure that that the data is actually safe and secure, even if we process it on such a leaf site. Maybe we can go back to the questions if someone has any. What about added emissions for the logistics involved with doing server maintenance in the leaf site apartments? Also a great question. We happen to have a bug feeds that we actually use to go to between our office, which is also in Amsterdam, and the different leaf sites. And the distances are really small. Also, these leaf sites have quite some capacity, so we also don't need to have a ton of them per se, and can do that with a lot of efficiency. We don't have to go there that often. What are the main requirements for the building to become a leaf site? Also a good question. We're actually very picky. We typically work with a couple of like big providers that have many buildings. But the requirements are that they are close to our data center, 10 kilometers or less, that they have a central heating installation that we can feed into. Typically that they are also willing to pay for the installation of the connecting of our servers and heating system onto their heating system. Because the deal is actually that we give them heat for free, and then they give us space for free. Which then in turn also helps us reduce our costs tremendously, and like not having to pay for these data centers, which are actually quite expensive. Why do you think migrating our code base to Rust would reduce CO2? Well, Ruby and Ruby on Rails are notoriously energy hungry, and Rust is known to be very efficient. So actually just having more performance in your application, especially those that of course do a lot, could actually simply increase performance, and more performance for the same amount of users means less servers. Lots of questions. That's cool. I like the fact that we get lots of questions. So let me take one more, and then I'll continue with the presentation. Do you have insight on how Leaf Cloud performs compared to other cloud providers? Are there noticeable latency differences due to geo-topology of your cloud? We actually did quite extensive benchmarking at the beginning to compare the performance of our VMs against those of AWS and some other cloud providers. And we actually show that we get more IOPS and higher throughput on all the common instances that there are. We're just upgrading also now to like 100 gigabit networking and like have a super fast storage cluster. So we can actually beat most of the metrics. But that, to be fair, like if you want to pay for all the super high performance at some cloud providers, you can probably get more if you really want to, but the price is also going to be very high. And so for the common types, we easily beat them typically. So just to be rounding up, what can you do on Leaf Cloud also? Like basically anything. Like we talk a lot about Kubernetes because it's obvious fit. AI machine learning, high performance compute, CI/CD, web application hosting, and then image and movie transcoding. All these kind of workloads fit great. And then just what we offer is server storage, networking, Kubernetes, object storage, load balancers, and cloud, of course, is scalable and programmable. We're all fully OpenStack based. And OpenStack, which is cool also to tell, is like helps us also build this infrastructure in a quick and reliable way. And there's a project, Masakari, that also helps us with the quick failovers and high available monitoring on these servers to make them not fail if needed. So thank you for listening, and I'll be happy to answer some more questions.
More questions. Okay.
Wow.
Do you use a low or high temperature cold heat net?
We do not connect to the city heat net, if that's the question. And I'll explain kind of like what it is. Oftentimes people ask me, oh, right, like, can you also make a data center more efficient? Or data centers also can be connected to the heat nets of the city. One of the issues there, and why we think that our approach is better, or what is flawed with the other approach, is that high temperature heat nets, they need 110 degrees Celsius input, and then typically give 80% or so, 80 degrees Celsius or so output. If you use that to move over, and this is cheaper to install over large distances, kilometers. Low temperature heat nets are, well, 20, 30 degrees or so, low temperature, but they need much bigger piping to actually do something with it. And so we do neither. We actually use extremely fast and extremely thin heat nets, which is the glass fiber optics. Like my colleague likes to say, we use the glass fiber network as our heat net because we move the work instead of the heat. Yeah.
Another question is this Leaf site setup secure enough to pass ISO certifications?
Yes, in fact, we have completed all the audits, and I'm literally waiting for our paper to come in the box. It should be here within a couple of weeks, or not here in Amsterdam, which is where we hold our office. But yeah.
Okay. I guess we can do two more questions. Regular housing does not have a redundant power supply like a data center. So are these instances only suitable for short-lived or resumable workloads?
Yes, exactly. So like, as I explained, we don't outfit these places completely like data centers. We do have like some amount of battery backup. So for if there's a short-term power outage or something, nothing happens on your workloads, that is. And then the question is, okay, so what kind of reliability do you expect? Like, typically what we see is that on these leaf sites, rarely, if ever, something happens for it to fail. Yes, it might, and we want to make sure that your data is not unavailable during any kind of longer period of time. That's why the system is built like this. But we can already give like a 99.9 or something reliability on the actual leaf sites. If we have an outage every month or something, like, which we don't, which gives it that thing. That also being said, if you have something that you expect the highest single instance availability, you can also run those instances in our core infrastructure, where we also have capacity. And there you do not have the most energy saving potential, but you do have the highest possible uptime. So if you want to run your database in our core, that's cool, and we can help you do that as well. And it's honestly, it's just as easy. It's a little bit more expensive because we like you running on the leaf sites, but that's an answer to this question.
Okay, and then the last question before we go into a short commercial break. Do you allow expensive blockchain computing on leaf sites? Please say no.
The answer
way
is
too long to say no.
The answer is no. In the policy, we disallow this, and also we try to block it as much as we can. It's for a while it was a problem because people just love using free resources and just like mining on our servers or something. But we do try to like block this.
Okay, thank you.
Thank you, guys. Thank you.